Hello again and welcome back to another episode of Hunting Liquid Damage. We're going to be giving this DPA D-Fine 88 microphone one more chance before I toss it out. The issue that I have is if you move your head from left to right or up or down, it's so fucking flimsy. It is so flimsy compared to the DPA 4065, it's a joke. This wireframe mic, you put it on and it stays in place. You put this on and you can probably even see it vibrating back and forth. It drives me absolutely out of my mind. But we're going to give it one more chance before I wind up giving this thing away on YouTube for free to a member of the audience. So, today we're going to be going over an 820 3437 motherboard, and this motherboard does not turn on. We do get a light in the charger, and we are going to be hunting some liquid damage. As you can see over here, we do get a light in the charger, and we are going to turn the light back on, and we are going to look through this board to see if we can find where the liquid is. So, can you find it? Do you see it? First thing we got to do is make sure that the focus matches, because for some reason there is a little gremlin that takes this and makes it out of focus. This thing does like to go out of focus. What I think happens is there's a gremlin, and I think that gremlin sneaks in after hours and makes sure that my microscope is out of focus. All right, there we go. Are we in focus? We are in focus. All right, we are zoomed out to 7x. One thing that I like to bring up to all the people that ask me about microscopes and which one to buy and the zooming and all that, well, that's on the SSD, so that doesn't really count. Ew! It's a pube! Look, it's a little pube. Say hello to the little pube. It's a pube that's growing in a culture of... Oh. Yeah, and people say that Jägermeister is the reason I'm going to throw up while I'm working. No. Anyway. Look, there's another pube. Look, this one's even moving back and forth in the wind. You guys see that? Look at that little pube moving back and forth. Look at it. Isn't it adorable? Just waving back and forth in the wind. A lone black pube in a sea of blonde and brunette pubes. Anyway, as I say, the reason that I don't care about super zoom is because, like, you're not gonna find liquid damage like this. This hurts. You find it at a lower magnification. It's like high up. Hey, what do you know? Look at this connector over here. It has liquid damage. And we're going to remove it because it has liquid damage. And I bet that this is probably going to work when we're done. So this is a good time to go over what I believe a common misconception is that people get themselves into. I'll find a lot of people that they'll find liquid on the board on one of these diagnostic ports, and they'll go, oh, well, there's liquid here, but that doesn't matter. The liquid in that port doesn't matter. That's not important. And the reason that is BS is because this little port over here is literally for everything. So over here we have BIOS. So we have, let's see, SPI. We have a bunch of SPI stuff. We have SMC mode. So this is going to set the SMC mode. We have SMC reset L, which is going to select whether the SMC turns on. We have programming lines for the SMC. So right here we have a direct line to the BIOS, a direct line to the SMC, and also a 5 volt and a 3 volt power line, and I'm pretty sure that there's a ground on this connector as well. So pretty much every important part of the machine goes to this connector. BIOS, SMC, modes that decide what mode the SMC is going to be and whether the SMC will even turn on, along with a 5 volt, a 3 volt power rail, and ground. If I wanted to destroy this machine and I had one drop of water and I had to choose exactly where I put that one drop of water to guarantee that I destroy the machine, if this were a game show, I would drop it right on that connector. But so many people think that connector is not important, it doesn't matter, and this is what kills me. Now here's what we're going to see if this microphone is better than the others, by the way. Noise reduction when I have a bunch of stuff on. This is a cardioid microphone, and the whole idea with a cardioid microphone is that it blocks out noise from external sources. I will say that the Shure SM35, while it sounded like shit, it did sound like shit, it was better at blocking out noise from the air filter because it was cardioid. One thing that I was particularly surprised at when it came to this microphone is that it actually seemed worse at blocking out noise from the air filter and other sources than the 4065. And the reason I thought this was silly is because the DPA 4065 is omnidirectional, whereas the DPA D-Fine 88 is cardioid. And I think that's because it's so difficult to actually figure out where to even point this thing. Oh, I'm gonna show you that at the end of the video because I don't want to ruin the sound right now. I'm not kidding. This doesn't even have a mark on it to tell you which end is the end that you talk into. Like, you can't make this shit up. It doesn't. You don't even know which end is the end that you're supposed to be talking into. Because the end that you talk into and the end that rejects sound on the DPA Define 88 that I received have the exact same marking on it. And again, you know, if it's a $50 microphone, I can't bitch. But this thing's like, it's like fucking $500. Like, fuck. Anyway, so we're gonna get rid of all the liquid stuff here. All the. Now, what I'm doing here is I'm gonna keep track of the pads that look a little screwed up, because if it still doesn't turn on, that tells me where I should be looking. So, this over here, the second one on the top, little disappeared, little burned out, and over here, this one over here is burned. Actually, this is the first one on the top. That doesn't count because it's ground. And this one over here. So the fifth one on the bottom, which you can't see unless I do this. Here we go. This one over here, it's totally missing. So if this doesn't turn on, I'm going to look over those sections, and that's where I'm going to continue my troubleshooting from. But if it does turn on, and it would be beautiful if it did. Oh, but it doesn't. Okay, so we actually do have to do a little bit of thinking here. Lame. All right, so let's see what those connections are for. So the first one on the top is going to be PP3V42, so that means that there was ripple on PP3V42. And then the next one is going to be, let's see, the fifth one on the bottom. So 1, 2, 3, 4. Okay, so PM clock run L had some corrosion on it. And PP3V42. So let's think to ourselves here. If PP3V42 had corrosion, so let's see where these items go. So PM clock run L. PM clock run L. Where do you go? I might as well look it up in here. PM clock run underscore L. PM clock run L. Okay, that is a pull-up resistor for that signal. Oh, lame. PCH power management. Oh, that is not making me feel good, man. Okay, that's a way for the PCH to communicate. That's a way to communicate with the PCH, because it doesn't go to anything else. This is a pull-up resistor that will pull up that signal. And that's, is that? It says bidirectional, so I'm assuming it's some sort of data line. But that's a data line for it to communicate with something outside the machine. I can't imagine how that would be important. Now, if that did get a hit of 16 or 12 or 5 volts, that's not going to be a good thing for us, because if it got a hit of that, then that means the PCH got killed. And I really hope the PCH didn't get killed, because if it did, that means that this entire thing is a waste of time. Now, let's see. What is... Huh. Let's see if I get any voltage at that point of the board. And I get nothing. So that is interesting that I get nothing over there. So that is being pulled down. So clock run low. Huh. Okay, where is that resistor that it's supposed to show up on? That, yeah, let's move this around so it makes sense. So PM clock run L is getting pulled up by this resistor that is in the middle of nowhere. Ah, but that gets pulled up when the machine is in an SO state. We're not in an SO state, so that's not supposed to get pulled up yet. All right, so we're going to move on to the rest. So what could... PP3V42 became corroded. PP3V42 had a shock. Now we're just going to look for all the things that could have been corroded along PP3V42. And see if we find anything that is nasty. Let's see. This is a long PP3V42. So let's see what we have over here. Do we have something that looks healthy over here? Remember, you have to chase using the hints that you have. Oh, duh. Plug it back in. It's there. What do you know? Corrosion by the clock area. That's a good hint. Now do keep in mind that the clock chip is actually powered by PP3V42, which had ripple on it. So that doesn't... all right. So let's clean up this area just a little bit, just in case that corrosion is doing something to our circuit. Get the air filter back on. And let's do a little bit of preliminary cleaning. Shouldn't have got that on the crystal. This chip doesn't look great to me. Something strikes me as funny about that chip. I'm not going to trust it. We did get water over there, and it's very easy for that chip to die as a result of water. So it's got to go. Now we're going to try to find a board that doesn't have water on it to take that chip from. But I seem to have stolen it from everything in my pile. Great. Here's one. Okay, so first thing we got to do is take that thing off the board. This is along the PP3V42 line, and it had water around it. So I'm satisfied that I have enough evidence that supports that this could be bad. And it flew. Yes, beep, HAKKO, beep. Hopefully the cardioid microphone is blocking out its beeping. We'll see. We will see. Keep in mind, this microphone should perform better than the other one for the specific task I have, because I'm asking it to not pick up noise when noise is all around it and it's right next to my face. For all the things that the SM35 failed at, that microphone was a cheap piece of crap. The one thing that it did better than the DPA 4065, isolating, getting rid of the noise, getting rid of the air filter and all that. May have sounded like a piece of shit, sounded like I was underwater. You had to apply like a high pass filter at like 180 hertz in order for you to not sound like you were underwater. But it did do that right. So if this cardioid microphone at its price can't do that right, then it can get the F up out of here. Anyway, that being said, let's get a clock chip. I'm grabbing a clock chip right next door. All right. This is one powerful station. Okay, now we're just going to get rid of that solder blob on the side. Clean it up, make it look a little nice, work a little nice, and see if we have a working board. Get that. The best time to do the cleaning, a little bit of preliminary cleaning, is while it's still hot. It'll help the ultrasonic later. The ultrasonic cleaner does a good job, but if you get rid of the really nasty stuff while it's still hot, it helps everything out, helps everything along. Okay, so we turn on, we put the charger on, and it's still dead. Well, great. Okay, so now we're just kind of flying blind since all of our hints... Huh. What's you? What be you? Oh, this is for SO power good circuitry. That's for getting it into an S... This is for getting into an SO state or sending all power good. We are so far from that. That's irrelevant at this point. There clearly was some dirt that got in this area. You could see all that red shit coming off. I broke that trace. Even though it was scraping, it shouldn't have broke that easily. Okay. Yeah, that... It didn't... I may have ripped that off. But it didn't look like it was on there that secure to begin with. Anyway. Good riddance to fucked up shit. Let's just take that off. Draw myself a wire. Come on. No patience. Go, get out of here. Get out of here. Alright, good. You're gone. Now. Not the nicest wire in the world, but this is not what I'm good at anyway, so... come on. These trees will suck. Yeah, there we go. Now let's get that component from something. This mic is such a fucking pussy. Like, as the wire moves at all, the mic moves. And you may be thinking, Lewis, get a clip. You get the clip, but still, even if you clip it to your shirt, if you move your head between the clip and the microphone, that length of wire will have the capability to move. You genuinely have to tape this thing to your face for it to not move. I've never been so disappointed with anything made by DPA. I could just be an idiot that doesn't know how to wear a microphone, but still. That could not be on more jagged. That could not be more jagged, man. And you know what? And somebody else walks in. Great. That was a crybaby. I told somebody that we don't fix the iPhone 6 Plus screen. Their best bet is Apple. He just stared at me for like 20 seconds before going, I don't know how you can do that in front of your girlfriend. I would prefer to not show my girlfriend that I'm a 2-year-old. But maybe that thing again. I am single, so what the fuck do I know? Anyway. With this type of soldering, who the hell is ever going to go out with me? I will never get a date as long as my soldering is this bad, as long as everything I put on is crooked. All right. Do I... And another person walked in. And the fan spun, though. We'll celebrate the fan spinning. Somebody asked me about a while you wait data recovery. I gave them DriveSavers information. You know what? I think I deserve a DriveSavers affiliate account. I refer so many people to DriveSavers. I refer a lot of people to DriveSavers these days. I mean, you know, like when they say, oh, 300 or 400 for phone data recovery. Pff, here, you may want to try these guys. They're a little cheaper. I love doing that. I love doing that. Like, I know it's mean, but I just love doing it. People are like, you know, I can't wait 3 days for this or 5 days for this. All right, try these guys. Wait till they hear. $2,400 and we get it when we get it. Anyway, as you can see here, the fan is spinning, which is the end-all be-all way of telling that this is a working device. So all we did is we just followed the liquid damage, and let's just go over the piece that was keeping this from turning on. There wasn't even a lot of measuring going on here. So the piece that was keeping us was Q8150. So let's look up Q8150. This is used. Okay, so PP5VSO is going to go in there. PP3V3SO is going to go in there. And PP3V3S5 has to work. So ultimately, if these rails are good, and PP1V5SO is there, then it will let out all system power good. But PP3V3S5 has to be present, PP5VSO, PP3V3SO, and PP1V5SO. If each one of these rails is present, you will get all system power good. Now, we did have a broken trace over here. We did have a very damaged and rusted looking trace between R8153, where's R, here we go, from here to the base of Q2, which is transistor 2 inside Q8150. So Q8150 is a transistor, multiple transistor package that just has what looks like, I think, like one MOSFET and 3 bipolar junction transistors, is it? Something like that, inside of one package. So all sys power good was probably low because the pathway from here to here was broken. And that's that. And as always, I hope you learned something.